Thank you very much, Ingrid, for this wonderful and generous introduction. I must say that in my life I've been introduced by clinicians and scientists and often by former patients, but never by someone who's an inpatient at the moment. So true honor. And it is really a privilege to follow you, Fiona. What a remarkable career and how inspiring. So look, I thought I might tell you a little bit, as it says, lessons from across the world, to let you know where all across the world I've been. So as you see, it's almost full round. It hasn't completed back completely. But this is where it started in New Delhi, India. And I thought I'd lead you through a journey. Since I look around, I see many of you were not even born when I started my medical career. So I thought I might give you a little feel of how a medical career evolves over a lifetime, how decisions get made, how opportunities come, how sometimes you take the right road and sometimes you take the wrong road, and sometimes you do it for the right reason, and sometimes you don't even know why you do these things. But nonetheless, for me, look, I grew up in India, my parents were there, and at that point in time, the question was, why did I do medicine in the first place? If you were growing up in India in the late 1970s and you were middle class, you basically had four choices. You could either do engineering or you could do medicine, or you could go into the civil service, but the way you did that is you completed a university degree and took an exam, or if your family had a business, you joined the business. There weren't really that many other choices one thought of. Now, my family didn't have a business. I didn't want to do civil service. I wanted to be in science, so it was engineering or medicine. Just happened to be that my father was the dean of engineering, so I thought that's not something I want to do. But more importantly, in the neighborhood, since we lived in a university neighborhood, one of the very inspiring people was a cardiologist who was the head of cardiology at the local medical school. And not only was he that, he was a well-known international scientist studying rheumatic heart disease. His name was Professor Wahi. And he used to fly around the world at conferences. And frankly, that is as much I knew about medicine and medical research, and I thought that would be a good thing to do. So there is me, some about 40 years ago, and at that point in time, to get into a medical school in India, you didn't have to write long essays, you didn't have to do any prior exposure or go work with doctors, you just needed to get a mark. So that's what I did. I got the marks that I needed, and I was fortunate that I got into a medical school. So perhaps the first lesson is that sometimes you'll end up making the right decision for the wrong reasons. By the way I see medical students now making decisions, they're so deliberate and thoughtful, and they give you such good reasons of why they want to get into medical school. Look, I did none of that. Gave an exam, got a mark, got into a good medical school. Well, this is what the medical school looked like. You see these very inspiring people, the statues of these people who were going to change the world. That's not what I looked like. That's what I looked like about 35 years ago. I was so pleased to be in a white coat. I thought, this is good life. But look, it was a good medical school. Other than the fact that there was this neighbor who I was fascinated by his world travels, I didn't go in there trying to be a clinician scientist. I just went and be a doctor. And it was a good medical school. It gave me experience of what by India's standards was sort of intensive hospital care, but also a very good rural and community exposure. And so we used to have rotations which took us to different parts of rural, regional India. That is actually me trying to write a prescription. Now, interestingly enough, I wasn't as yet a doctor, I was a medical student. I realized we used to write prescriptions. Don't ask me how that used to work, but it did work in the villages. What you might not notice is people used to bring you samples, so that's someone bringing a tapeworm in a little bottle. So that was the wonderful exposures that one had there. But it was in my community rotations that I got to know someone who was at that point in time an associate professor of community medicine. And this was a very remarkable person, and this is him. This was Professor Chandrakant Pandav. He led the WHO's effort against endemic goiter. Now, many of you might not know what that is. So this is India. This is the northern parts of India in the Himalayas. And because of the way the rain falls, etc., and the way salt comes, it's sort of bleached and there is very little iodine. So this part is actually deficient in natural iodine, and as a result of which women develop this little thing, goiter. I'm sorry, I got this off the web, so you can not see the goiter, but you can see the sort of swelling in the neck. So women used to develop goiter, which was actually a physiological compensation. So this wasn't by itself a bad thing for the women because their thyroids had expanded for the deficiency of iodine, were still producing enough thyroxine and everything else. The problem was for their children. So the children born to such mothers tend to be iodine deficient, and as a result of which develop varying degrees of neurodevelopmental problems. The solution is remarkably simple. You just need to put a bit of iodine in the salt. To do it for 320 million people is not an easy thing. So that was the WHO effort he was leading, and I got as a summer student to be a part of his program. I was very fortunate as a part of it that I got to actually publish a paper. I was very proud of it. It had to do with iodine assessments, and that gave me a first insight in how remarkably simple things like iodine and salt could change the life of 320 million people. But it also gave me a sense of how it ain't that simple, because there were all sorts of socio-political and business problems to putting iodine in salt, including some local businesses who were now losing business because instead of traditional salt, there was this packaged salt. And they started telling people, look, this is a part of sterilization effort by the government, where the government is surreptitiously putting, and he says, this is how I can prove it to you. I put this salt, and they would do this Bayonet's reaction or something, and it would turn blue. Clearly, if your salt is iodine, you can react it and make it blue. And they said, look, this is the government salt, turns blue. You take this, you're going to be sterile forever. Take my salt. So this just gave me a sense of the complexity, that it's not just about science. It is to be done in this very complex environment. But this was community medicine. I did this, but as I went into my clinical years, I got very interested in psychiatry. And I got particularly interested in psychiatry because as a part of my clinical rotation, I saw some psychotic patients. Now, interestingly enough, there wasn't much of psychiatry research going on at the All India Institute of Medical Sciences. So at that point in time, I had to make a decision, and I said, look, I want to do psychiatry, I want to do research, though I really didn't know much about psychiatry or precisely which kind of research. But nonetheless, I thought to do that, I had to go to a center of psychiatry. So that's the next step. So that took me from New Delhi, India to the University of Pittsburgh. And why Pittsburgh? It is one of the leading centers for modern psychiatry. Now you'd say Pittsburgh's a very odd place to be a leading center of modern psychiatry. Much of the exciting stuff happens here along Boston, New York. Well, here was the problem. In 1950s and 60s, indeed, much of the exciting stuff in psychiatry was happening along New York and Boston. But the exciting stuff in psychiatry in 50s and 60s was Freudian psychiatry and psychodynamic theories. So the renegades from the East Coast decided to do something different. They decided to do neuroscience. Well, you couldn't do it because that's what the Northeast did. So they actually moved to Pennsylvania and they moved to Philadelphia and Pittsburgh, and the bastions of what subsequently became neuroscience-based psychiatry started in Pittsburgh. And that's what I wanted to do. And I was very fortunate that the professor at the All India Institute of Medical Sciences, Psychiatry, had a colleague in Pittsburgh. Now, mind you, at that point in time, I was in India. There was no internet, so you had to write letters of your application. And I didn't even have the application forms to apply for an American residency because you got to first go take an exam and do all of that. So I hadn't done all of that. But because of this professor who knew someone else with whom he had trained, I was able to go to Pittsburgh. And I was very fortunate. So this is the professor who was the friend of my professor at the All India Institute of Medical Sciences, and that's Professor Keshavan. And he was at that point in time an associate professor at this place at the University of Pittsburgh, which was this massive center of neuroscience. That entire building just did one thing, the neuroscience of psychiatry. And now, of course, you see it all over the place. We've got buildings like the Florey, but you've got to imagine this is something like the Florey, built about 50 to 60 years ago in a place called Pittsburgh. But anyway, that's where I went, and this is, of course, Professor Keshavan, who was very good in receiving me. He was an expert in schizophrenia. He's now actually the Harvard professor of psychiatry. He's in Boston, so Boston's changed. Now they do neuroscience of psychiatry. And with him, I began to understand some of the sort of earliest fundamentals of psychiatry. And now a psychiatry residency training at that point in time was 4 years. So I did some of my first clinical training with him. I developed an interest in schizophrenia. And at that point in time, he was interested in using a brain imaging technique called MR spectroscopy. So I got interested in that. But the problem is we were psychiatrists. The MR spectroscope was controlled by the neurologists. And the psychiatrists rarely got any time on it. So I kept thinking about it, but couldn't do much research. But nonetheless, I tell you these stories to point out that mentors and models, people, influence your decisions much more than facts, figures, and rational design. So the story that you've seen up till now, it wasn't that I sat down and said, this is the unmet need, this is now. You meet people, you get excited by them, you really get excited by their passion, or at least I got drawn in by the fact that they were so passionately excited, just as Fiona is about burns. If she was my professor, I'd be doing burns. But you just get excited about people and what they're doing. And that's how at least some human decisions get made. But that got me into it, but then I couldn't pursue imaging in schizophrenia because that was just not a possibility. And then my rotation and as a resident went into depression. And then I had a second very seminal influence, and that's Professor John Mann. Now, interestingly enough, I didn't know how stories come, but John is actually a Melbourne graduate. He graduated from here in 1980s, went and established a career at the University in Pittsburgh, and was one of the world leaders in depression. Now, I'd started off with an interest in schizophrenia, couldn't take that any further, so we moved into depression. But from him, I learned about the neurochemistry, so we were able, while I was a resident, to publish about the dopamine system in depression. Then, because he had a basic science lab, I was actually able to go into the lab and start doing animal studies. Because we still, at that point in time, couldn't study dopamine in the human brain. This is the sort of mid-1980s. So this technique called PET imaging was just coming around, but it actually wasn't there for us to use. So I started working in rats and started studying the dopamine system, and I got a better sense of how things work. And now they were just going to acquire this thing called PET imaging, which would allow us to look at neurochemicals in the human brain. And my residency was about coming to an end, and I thought, this is great. John Mann's a great mentor. They're going to have PET scanning here, and this is what I'm going to do. But what this emphasized to me was a strong relationship with basic sciences. So if you are going to be a clinician scientist, a very strong relationship with basic sciences, which can be done in many ways. It can be done by having your own lab, or it can be done with a very strong partnership with a number, is critical for a lifetime of renewal of your clinical investigations. Because if you don't have that relationship, you'll start off on a certain career, and then you'll end up doing just parametric dose comparisons, because that is what you can do, unless you can go back to the basic lab and bring something new and exciting back into that space. So that was my plan. I thought, great, I work with John Mann, we do PET imaging. The university had ordered the PET center. They had also created a position for me to do it. And then darn, this thing happens. So I'm in the United States. I told you I came from India. I was on a visa. I hadn't even taken notice to note that in the J1 visa, there is a little line there saying that when your training finishes, you have to leave the country for 2 years. I hadn't actually quite planned for that. So all my plans of doing depression, PET, so what am I going to do next? So I quickly looked around and said, where are they opening PET imaging centers? I thought, I'll go to the nearest next PET imaging center. And I was very fortunate. That happened to be in Toronto. And I was further very fortunate that a PET can be used for many things. It was beginning to be used for the brain, largely with the neurologists of Parkinson's disease who were leading it. But in Toronto, of all the places, there was this person, Professor Jacques Cleghorn, who personally did not know much about these technologies, but could see the value of these in psychiatry, who had managed to actually get a PET center in an institute of psychiatry. So I thought, look, that's where I'll go. And that is me at that point in time. This was our new PET scanner at that point in time, now about 25 years old. But the important point I want to make is that there weren't any psychiatrists doing PET scanning at that time. In fact, the psychiatry leader who had acquired a PET scanner didn't actually know anything about it. He was just influential enough. He knew this would be an important technology. So here I had to work with Alan Wilson, who was a chemist from Johns Hopkins University. Here was Jean de Silva, who was a physicist coming from McGill. And here is Professor Sylvain Houle, who was a professor of nuclear medicine. So here was I, a psychiatrist, trying to insert myself into this group of people. But the point I'd like to make here, that technological advantage in science matters a lot. So you cannot do world-class research with just good ideas or alone by yourself. So you have to find a way, and I think Fiona's examples tell you that technology is a very big part of modern clinician science. So I was very fortunate that with that, it gave us the opportunity to now look at the human brain. So rather than studying dopamine in rats, using this thing called 11C raclopride, So this is a tracer. So what you do is you take this drug called raclopride that binds to the dopamine D2 receptors, and you label it. And because you label it, it emits positrons. So when you've given it to the patient, the drug goes and binds to the dopamine D2 receptors, and wherever you have a high concentration of it, you get a high signal from it, and you can pick it up in your PET camera. So that's a PET scan, that's an MRI scan, and you can see these highlighted areas in the caudate and the putamen tells you there's lots of dopamine D2 receptors. Now what we were then able to do is that if you take this patient and you treat them with an antipsychotic drug, their scan looks like this. And this was the first visualization of a drug working in humans. And not only could you get a picture, you could actually quantify, and you could say that 74% of their receptors were blocked by the drug. And this was one of the first sort of examples in humans where we could do this. And the immediate implication of it was that we realized that the Haldol doses we were using at that point in time were somewhere in the range of 10 to 20 milligrams a day. And here we'd shown that just 2 milligrams. And of course, patients used to get a lot of side effects, and we just thought it was still necessary, that we had to use it in 10 to, certainly in psychiatry. And there were some who had this idea of rapid neuroleptization who used to give 100 milligrams a day of haloperidol. It's no wonder patients survived, but they did. So we were able to show that very low doses, so relatively simple. So we do all this complex scanning, and its first big implication is that you don't need to use 100 or 20 or even 10. You can actually use 2 to 2.5 milligrams of haloperidol. And then we started doing more studies, because now we could do dose-controlled studies where we could give patients different doses, we could measure their blood levels, we could look at the effect in the brain, and we could look at the clinical outcomes. So we started drawing these relationships, and we were able to show this dramatic effect that there is something in the human brain that if you block less than 65% of dopamine D2 receptors, patients don't get better. If you block more than 65%, it's almost like a threshold, people do get better. But what we then realized is that if you block more than about 80% of the receptors, patients start getting Parkinsonian side effects. So we spent a lot of time mapping this, creating the framework of this, and giving psychiatric dosing in schizophrenia a sort of rational basis, if you may. Now, while I'm doing all of this, I told you I was a resident in Pittsburgh, so then I moved to Toronto. The Canadians said, no, that's American residency, you're not a Canadian resident. So I had to do 1 extra year of Canadian residency. And then I thought, if I'm really serious about this, I've got to do a PhD, so then I did a PhD. And I said, look, if I'm really going to stand up shoulder to the schizophrenia experts, I need to do a fellowship in schizophrenia. So it rather did take a long time. So, it took me I was 35 or 36 till I got a real job. So the next point is that becoming a clinician scientist is a marathon. So don't look over your shoulder at the sprinters or people who quickly gone and established their practices, got married, had their children, have their big house in the suburb. All of that stuff takes time. It will happen to you, and you can do it remarkably well, but the timing is a little bit different. You'll have to make some sacrifice, and a financial sacrifice will definitely be one of those. There are many other things you can reconcile, but money ain't one of those, or certainly not in the early stages of your career. But anyway, we kept doing this, and now we move into the 1990s. This technique becomes established, and suddenly in the 1990s, from that haloperidol that I was talking about, which was a drug, had been around for 50 years, there had been no new medicines for schizophrenia, out come these drugs called the atypical antipsychotics. So they're called atypical antipsychotics, and there's 6 of them that come in a period of 3 or 4 years. And a lot of these atypical antipsychotics, as they're released, they release these kinds of pie charts, and they show you that these new antipsychotics, they block a number of receptors, whereas the old one I showed you blocked just the D2 receptor. So all of these new, now it seems the game has entirely changed. These drugs work on different receptor systems, so it's a new way of treating schizophrenia. And if you just look at these pie charts, you might think, well, that's probably right. There's very little yellow, there's a lot more of these other colors, maybe that is what has happened. And of course, a lot of this was derived from animal studies. But of course, what you're really interested in what happens in the patients at the dose where the drug is actively effective in patients. So I'd shown you this sort of 65%, you've got to block 65% of the dopamine D2 receptors. So what happens with these drugs when we give them to patients? So then we systematically, over a period of 10 years, mapped these drugs in patients. We looked at what happens at different doses. And of course, before, you can't immediately do these studies in patients because they're rather expensive and they take time. So we developed an animal method. So this is, again, the value of working with basic scientists. So this is a PET scan in a rat. You can't, at that point in time, the scanners were not good enough. The resolution was not good enough. So if you put the rat in a scanner, all you saw was a little sort of blob. That wasn't helpful. Now, of course, the scanners are good. You can scan them just like humans. So what we did was we developed these probes, which were the same probes that sat in the camera, but instead of having them sit in the camera, we actually inserted them into the rat brain. And then while we couldn't get pictures, we could actually get very good graphs of the same ligand, of the same scanning technology, and we were able to then map all of these things and how they happen in animals, and I won't bore you with that. But essentially what this allowed us to do was now study this new range of drugs in patients, and here was what at that point in time was very surprising. So this is that new drug risperidone. As I showed you, had a very thin sliver of yellow in a test tube and in rats. But in humans, in the doses where we use them, and we still use them in these doses, about 2 to 6 milligrams, you actually see it blocks about 70 to 80% of the dopamine D2 receptors. So in some sense, this was very useful for the field to realize that actually, even though these drugs look very differently in a test tube, when you actually use them in patients, they're quite like the old drugs. So which was a rather underwhelming story, because we thought we had come to a new frontier of treatment, but actually we realized we're still working through the dopamine system. So look, we went on and did a lot of this work. But now you might think, well, that's like 15 or 20 years of a person's life spent just looking at this dopamine D2 receptor from the left, from the right, in blue and in red. I think I would have to bring to you that if you want to become a world expert in your field, you have to first become a world expert in something very niche. So, to many of you, it may seem like, schizophrenia, well, that's just a little part of psychiatry. No, a schizophrenia conference now has about 1,500 people show up every time we have that conference. And the way sort of scientific reputations and scientific credibility build, you have to become really, really very good at something. And then actually people invite you to do all sorts of broader things. And this is an important lesson for the younger people in the crowd, that of course you'd look at people like Fiona and Ingrid and you'll say, well, these people do so many things, they lead societies, they invent, they do this, they do that. So let me start by being a little bit of this in all the areas. That's actually not how it works for most people. You have to establish your credibility and earn your stripes within a field by becoming exceptionally good at something niche and almost becoming a world leader in that one very small area, and then the world opens up for you. It certainly did for me. So that was me in Toronto, and then I was very fortunate to be invited to compete for the position of the Dean of this Institute of Psychiatry in London. Now, this was an honor because the Institute of Psychiatry, which looks like this, now this was the first major English language institute of research in psychiatry. So this opened prior to the First World War. It's called the Maudsley Hospital. But more importantly, it owes its lineage to a psychiatric hospital that goes back to 1247. So this is the home of psychiatry in the English-speaking world. The reason I say the English-speaking world is because in Istanbul there's actually an older mental hospital. But nonetheless, and this is actually an interesting one. So prior to this, it used to be the Bethlehem Hospital. And the English word bedlam for madness actually comes from the hospital. Because people used to call this Bedlam, the hospital, they just didn't say Bethlehem, they said Bedlam. And people used to go to Bedlam to actually see mentally deranged people. It was like a reality TV show. So actually on Sunday, you have pictures of people dressed, paintings actually, of people dressed in their Sunday best, being led by the superintendent through the Bethlehem Hospital to see patients. Anyway, so the world was. But over time, this great hospital and this great research institute developed this Institute of Psychiatry, Psychology, and Neuroscience, and that is where I was. And this is where we went, and we further went and nailed every aspect of schizophrenia. So we looked at dopamine synthesis, dopamine release, so we actually looked at all of it, increasingly with other colleagues who were doing the work, and I was largely supporting it. And we were able to draw a very good picture of the biochemistry of schizophrenia. Now, as this is happening, of course, One of the beauties of being in Europe is that it's a very large spectrum of science and scientists, and the EU was working and was developing new programs. So I was very fortunate that through my work in schizophrenia, I was then able to lead a pan-European consortium called NewMeds, which was a European partnership of about 10 pharmaceutical companies, about 9 universities, and some small and medium-sized enterprises to develop new medications in the area of schizophrenia and depression. So even though I'm only a schizophrenia scientist and actually had some vague association with depression with John Mann some 20 years ago, this was an opportunity to now broaden beyond my own very narrow interest and work with a very broad collaboration of people who are chemists, medicinal chemists, geneticists, structural biologists, to try and develop new methods for new medications in schizophrenia. So that is what I got to do for some length in time. And I think the lesson from all of that is that it is easier to good work when you can stand on the shoulders of giants. So you can see that at this point in time, my own expertise is in this very narrow area of dopamine and schizophrenia as measured through PET imaging. But by virtue of my collaboration with these geneticists and structural biologists and medicinal chemists, we at least tried, didn't succeed sadly, to develop new medications for schizophrenia and depression across Europe. But the other thing you realize as you go about doing that is that actually the world takes a complete circle around you. And this young man with whom I used to work, and perhaps I was a mentor for him, is now a professor. And I very quickly realized, and we were both working in this area and we used to work together, and that of course really he now was the world leader in this area. And while I was certainly supporting him, this was almost a complete cycle of where I would look to mentors and with their support do things. That here is a person who really, on his merit and with some partial support to me, has now become the world leader in this area and is taking it forward in ways that I could not even have imagined. So that is what I did in London. And as I was doing this, while I was a dean, I was actively still involved at the Institute of Psychiatry. I was actively still involved in my science, but getting increasingly involved in these pan-European consortia, developing some leadership skills as to how you get these very broad groups of people with different interests to work together. So at that point in time, I had to make a decision. Would I continue my work in psychiatry? Or as my interests were broadening, would I actually take on a broader leadership role in medicine? So I was very fortunate at that point in time that I was sitting by my desk. I still remember this. It's interesting, you remember the important moments in your life, and Fiona was talking about the pants she was wearing when she chose surgery. I still remember I was sitting in my office. Rarely do I get telephone calls because people usually call you on your mobile now. So this was a telephone call that came from someone from Melbourne. And life changes, and that is then what brought me here to the position as the Dean and Assistant Vice Chancellor for Health. And now this is a different job that I have. I unfortunately, or as a matter of choice, don't get as much time to pursue my singular passion in dopamine and schizophrenia, so I must say I've become more of a spectator of that field, a keen spectator, but not that much time. But it now allows me to work across a much broader spectrum within the university with our medical research institutes, hopefully to foster the next generation of people who will bring about change. So I hope this gives you a little bit of a sense of my own journey. Everyone's journey is going to be different. But if there is perhaps one lesson you might want to take away, particularly when you hear people like us who've done it for about 30, 40 years, that post hoc you can make a beautiful story out of all of this. While you're doing it, it is an adventure. So you have to see it as a sense of adventure. There is no clarity because you do not know when you're a 20-year-old in New Delhi that it'll go like this. It could have gone many ways, and it could have still been as fulfilling. But in the end, you only have one life to live, and there's no controlled trial, so you do it once. Thank you very much.